Okay, good morning, everyone. Today, I will present a research paper on HYSYNTH, a novel automatic programming technique that employs the string of large language models. My name is Minh Dương, and my co-presenter today is Adi Kumar. So this presentation will cover the current state of program synthesis, detail the proposed hybrid approach, present the experimental results using with HYSYNTH, and discuss the methods, limitations, and potential future directions. So let's go with program synthesis overview. So program synthesis is providing the computer with a goal or a set of examples, and it figures out the code needed to achieve that goal in a domain-specific language. It is like teaching a computer to write its own code. So instead of manually typing out every line, you provide the computer with a goal or a set of examples, and it figures out the code needed to achieve that goal. The traditional program synthesis approach is based on combinatorial search, meaning that it will search for all possible program combinations. This works well for small programs and restrictive domain-specific language, but becomes infeasible as the program size and the domain-specific language complexity grow. On the other hand, another approach is using a neural model, i.e. large language model, to predict the program from input-output examples. So large language models demonstrate impressive capability in various domains, but they continue to struggle with tasks that require precision. For example, like structure prediction, reasoning, counting, or data transformation. So when direct task examples are not prevalent in the training data, large language model, unfortunately, even the state-of-art large language model like the GPT-4o struggle to predict an entire program in an unfamiliar domain-specific language. So motivated by these limitations, the paper introduced a hybrid approach where large language model completions for a given task are used to learn a task-specific context-free surrogate model, which is then used to guide the program synthesis. The paper experiments and evaluates a tool called HYSYNTH, which stands for hybrid synthesis. So the method and structure of HYSYNTH. So HYSYNTH starts from sampling solutions from a large language model. Next, HYSYNTH will attempt to parse each completion SI into a program PI using the grammar G. The resultant set of programs is used to learn a probabilistic context-free grammar GP via maximum likelihood estimation. Finally, HYSYNTH used the probabilistic context-free grammar computed in the previous step to derive a weighted grammar GW and uses it to initialize the bottom search procedure. As a result, the search is guided by the insight from the large language model. Next, we'll put the HYSYNTH into experimentation and evaluate its performance.
Thank you, Min. I'll take it from here. And so I'll be talking about the next part, which is experiments and results. So let's get started with the experiment domain. So for the experiment domain, the HYSYNTH model was instantiated on 3 domains. One of them is the grid-based puzzles, also known as ARC, tensor manipulation, and string manipulation. So if you go to the experimentation setup, the next slide, please. The experiment involved the model to be evaluated on 299 programming example tasks from the 3 of the domains I mentioned previously, with 160 tasks from the ARC and 70 tasks from string and 69 tasks from the tensor domain. Our main HYSYNTH configuration uses GPT-4o as the LLM with 100 programs samples per tasks to learn the PCFG in non-strict mode. For each, compare the performance of HYSYNTH with the baseline synthesizer for that domain, such as ARGA and Probe and TF-Coder, and as well as two ablations, which is no search, which uses the 100 samples from the LLM directly, and unguided search, which runs the same synthesizer but with the uniformed weighted grammar. We also analyze the performance of the HYSYNTH with different numbers of samples used to learn the PCFG with other LLMs, as well as in strict mode. The search timeout is set to 10 minutes for all experiments. And for the results, based on the diagram, we can observe that the HYSYNTH consistently outperforms the baselines set by the other models. GPT-4o seems to be effective in guiding HYSYNTH with the proper LLM samples. And the PCFG learning, larger sample sizes seem to improve the performance slightly, but even with fewer samples. So even with fewer samples, HYSYNTH is able to outperform the other baselines. So yeah. And we can also observe that HYSYNTH's custom synthesizer is outperforming ARGA in tasks for the ARC puzzles. Based on the diagram, we also observe that the guided versions are outperformed by the unguided search. And so yeah, we can then move on to the limitations and future works. So although HYSYNTH is extremely promising in program synthesization, it does have its limitations because HYSYNTH depends heavily on the quality of programs generated by the LLMs, as well as the effectiveness of the PCFG as a surrogate model. For the future work, to potentially overcome all of these issues, we would need to improve the ability of LLMs to generate programs that are syntactically and semantically meaningful, as well as using more advanced probabilistic models that is able to capture the program structure effectively. So in conclusion, we see that HYSYNTH is a very effective approach for program synthesization, which combine the strength of the LLMs and the search-based models, which has given HYSYNTH the ability to learn from solutions generated by the LLMs and guide the search process to provide promising results across various domains. In the context of our current cohort, I believe this would be a valuable asset for the data science copilot team, since they would need to synthesize programs based on their users' needs efficiently and effectively. Thank you.